So we have seen the details of anode ray experiment, like how was the experimental setup, how was the experiment conducted, and some basic observation. Now what was concluded from this experiment, we will now see. So what happened? The results of anode ray experiment. What was the first result? The first result was they travel in opposite direction to cathode ray. So, cathode ray particles, which were the electrons, moved from cathode to anode. But the anode ray particles moved from anode to cathode. So this was concluded that the anode ray particles are positively charged, since they moved towards the negative electrode. So this was the second conclusion. Second conclusion was anode ray particles have positive charge. Now, the third conclusion was these rays produce bright spot on zinc sulfide wall. But the fourth point was very interesting. Unlike cathode ray, the positively charged particles depend upon the nature of the gas in the tube. So, in the anode ray experiment, what was seen, that the observations, that is the effect on the zinc sulfide wall, were different for different types of gases. That is, their results depend upon the nature of the gas that was present in the tube. But for cathode ray experiment, it was not like that. The results were constant. Why? Because if we see the dissociation, for hydrogen, we see 2H plus and 2 electrons. For nitrogen, it will be 2N plus and 2 electrons. For oxygen, it will have 2O plus 2 electrons. So what happened? These electrons are similar for all gases. So electrons remain same. But these positive particles were different for different gases. We know that the mass number of hydrogen, nitrogen and oxygen are different. Their atomic numbers are also different, that we will study in the later sections, but for now we know that they are different gases. So, the positively charged particles that were formed in the anode ray tube were not exactly some particles, they were gaseous ions. What are ions? When you take out one electron or introduce one electron into an atom, positively charged and negatively charged ions are formed respectively. The positively charged ions are called cations and the negatively charged ions are called anions. For now, we will not talk about anions. For now, we will concentrate on cations only. So, these ions H plus, N plus, O plus, they were gaseous ions. Okay, they were not positively charged particles. So, their observations were also different. So, next conclusion was naturally the E by M ratio, that is the charge to mass ratio for different gases were not same for all gases because the mass is different. Mass is different for different gases. The sixth point was some of these particles carry a multiple of fundamental unit of electrical charge. What is the fundamental unit of electrical charge? The charge of one electron is minus 1.6 into 10 to the power minus 19 coulomb. This was the charge of an electron. So, this is the fundamental charge. So, if protons are the positive equivalent of electrons, or if the protons and electrons, which were now called the anode ray particles, if the anode ray particles and the electrons together maintain the neutrality of the atom, then each anode ray particle must have equal charge to that of the total charge of electrons in that system. So, it was observed that for different gaseous particles, for some of them the charge was the multiple of fundamental charge, that is, for some of them the charge was, for example, the charge is Q for a random gas, the charge was Ne, where E is the charge of electron and N is any integral value. Okay. So, for some of them the charge was a multiple of the fundamental charge. But for hydrogen gas, the charge for each particle was obtained to be equal and opposite to the charge of the electron. That is, for hydrogen ion H plus, the charge was obtained as plus 1.6 into 10 to the power minus 19 coulomb. So, hydrogen ion was called proton. Remember, not all gaseous cations are protons. Only hydrogen plus is called proton. This is a very important thing. Only H plus ion is called a proton. All positively charged cations were not called protons. So now we will see some important factors of the proton. What was that? Let's summarize. First of all, the charge of a proton is plus 1.6 into 10 raised to minus 19 coulomb. The mass of a proton was found out to be 1.673 into 10 to the power minus 27 kg. If we convert it to AMU, 1 AMU equal to 1.66 into 10 raised to minus 27 kg. So the mass of proton in AMU was found out to be 1.007 AMU. Okay. Similarly, what was the mass of electron? Mass of electron was 9.1 into 10 to the power minus 31 kg, right? So if we calculate in the same way, how did we obtain this? It was like this. By so similarly in AMU, mass of electron will be was found out to be 0.000548 AMU. So what do we see? That mass of proton is very large as compared to mass of electron. When calculated, it was observed that mass of proton by mass of electron equal to 1836. That is, the mass of proton is 1836 times bigger than the mass of electron. So what was the charge to mass ratio for proton? The charge to mass ratio for proton was it was 9.5637 into 10 to the power 7 coulomb per kg. This was the charge to mass ratio for a proton, and the important factor here was mass of proton, or the mass, it is the mass of hydrogen ion, was not equal to mass of N plus, not equal to mass of O plus, and so on. Okay. So this was the conclusion from the anode ray experiment. So after protons and electrons were discovered, still there was no specific model about how to describe the structure of an atom. We had calculated the values for mass and charge of electrons and for protons as well, but still some concept of atom was needed, that what is the structure of an atom. So J.J. Thomson proposed a model for the structure of atom for the first time. That was called Thomson's plum pudding model. What was Thomson's plum pudding model? Before that, what Dalton said in Dalton's atomic theory, that atom is a neutral, undivisible particle, which was the smallest particle for a matter. But later on, when the electrons and protons were discovered, the structure of the atom had to be something like this. If this is one atom, it should have a positive part and a negative part. We now know that the negative part of an atom is called the electron. Negative. Negatively charged, and the positive part was proton. Okay, before starting the atomic model, another very important thing was that the charge to mass ratios of electron and proton, how did it correlate, or what are their comparisons? What was the charge to mass ratio of an electron? It was minus 1.758820 into 10 raised to 11 coulomb per kg, and for proton it was 9.5637 into 10 raised to 7 coulomb per kg. If we take the modulus of them, that is the magnitude, then there will be no sign. So magnitude of this is without the sign, that is and was what did we see, that if we compare these two values, this is 10 to the power of 11 and this is 10 to the power of 7. So basically 10 to the power of 11 is very large as compared to 10 to the power of 7. It is almost 10 raised to 4 times larger. So we can conclude that the magnitude of E by M ratio of the electron is very greater than the magnitude of charge to mass ratio of a proton. Remember that in this case we are talking about the charge to mass ratio of the magnitude of the charge to mass ratios, right? We will not take the true values, because in the true value the charge to mass ratio of electron we will have a negative charge and for proton there will be a positive charge. So now we know about the electrons and protons. Next we will study about Thomson's atomic model, which included both positive and negative charges. This was known as the plum pudding model, or the watermelon model. Next, we will study about the plum pudding model or watermelon model proposed by J.J. Thomson. Thank you.